In this lesson, we are going to be learning about depth of field. Depth of field basically is the range of acceptable sharpness within a photo that will appear in focus, or in simpler term, the parts of the image that are in focus. If the areas of focus are very small in the image, we have a shallow or a narrow depth of field. You can see in this render in the frame buffer in which the camera's target is on the clock, only the clock is in focus, and as we get closer from the clock to the camera or from the clock to what's behind it, the image gets more and more out of focus and blurrier. And this gradual change from focus to out of focus areas happens very fast. Here we say we have a shallow or narrow depth of field. On the other hand, like our next render, if the areas of focus are very large in the image, we have a wide or a deep depth of field. In this image, you can clearly see a larger area is in focus compared to our previous render. Now, let's see where we can enable depth of field in our physical camera and what factors control the depth of field in your render. Select the first physical camera in the scene. And as you can see from the top view, the camera's target is on the clock. In order to enable depth of field, you need to go to the physical camera rollout, and under the focus group, you can enable depth of field. If disabled, the entire scene will be sharp and in focus. So let's enable it for now. Right now, the exposure mode is set to target, so changing the aperture size wouldn't affect the exposure. The deciding factor on how narrow or wide the depth of field is the aperture size, which is being controlled by the f-stop number or f number. In the previous lesson, and as we can see in the frame buffer, we learned that smaller f numbers means larger aperture size, and larger f numbers means smaller aperture size. Now we need to add another concept here. The smaller the f number means larger aperture size and also narrower depth of field. And on the other hand, the larger f number means smaller aperture size and wider depth of field. Just to simplify this again, the smaller and lower your f number, the narrower or shallower the depth of field. And the larger and higher your f number, the wider or deeper the depth of field. Now let's see a few renders with different f numbers or f-stop numbers. Set the f number to 1.4 for now and take a look at the render with this f number. As we can see, we have a very shallow depth of field. In the next render, f number was set to 2. Still very shallow, but wider depth of field compared to our previous render. Then f number was set to 4. Still shallow, but again wider. Then it was set to 8, and finally 16. When set to 16, you can see we have quite a wide depth of field and most of the scene is in focus. So again, the smaller and lower your f number, the narrower or shallower the depth of field, and the larger and higher your f number, the wider or deeper the depth of field. For now, let's set the f number to 2. The next thing you probably want to know is how to change the focus distance. Right now, the focus distance is based on the camera's target, and the target is on the clock. If we want to make sure the books and the bottle are in focus, all we have to do is to make sure the target is on the books. So let's do that in the top view. Maybe a target distance, something like 152 centimeters possibly would work. Now, if we render the scene, the clock will be out of focus and the books and bottle will be in the focus. There you go. Let's set the target distance to be on the clock again. The exact target, I think it was 113.287. In the focus group of the parameters, if we don't want to use the camera's target distance as a focus distance, we can simply change the focus mode to custom and define our own focus distance. Another important factor in how narrow or wide the depth of field is going to be focal length. And the rule here is the longer the focal length, the shallower the depth of field. It's not as important as the f number, but it contributes. I have a second physical camera in the scene. Our active camera right now has a long focal length of 18 millimeter, but we have a second physical camera in the scene which has a short focal length of 20. So let's unhide it and make it the active camera. As you can see from the top view, its focus distance is on the clock. Let me enable depth of field for this camera as well and set its f number to 2. Now, if we render the scene and compare it to the long focal length render, we can clearly see that the camera with longer focal lengths produces shallower depth of field. The first render was done with our second camera, which has a short focal length of 20 millimeter. We get a shallow depth of field, but compared to our next render, which was done with longer focal lengths, its depth of field is wider. Now let's hide our second camera and go to the first camera again. Another important factor in depth of field is the scene scale. Basically, the smaller your scene and your objects, the shallower the depth of field, and vice versa. Let's go to the bokeh or depth of field rollout and see what other options we have. Bokeh, if technically defined, is the quality of out of focus or blurry parts of the image, or simply the pattern exhibited in areas of the image that are out of focus. In the bokeh rollout, first we have aperture shape. When parts of a photo are very much out of focus, the blurred highlights in the photo tend to take on the shape of the lens aperture. Right now the aperture shape is set to circular, so the out of focus highlights will have a circular shape. But if I select bladed and set the blades to 3, now we're gonna have a triangular aperture, which result in a triangular out of focus highlights. Instead of using only circular or bladed types, you can set it to custom and define your own bokeh pattern. If you want to get the same result as the circular type by using the custom texture mode, for example, we would have used a white circle that fills a black background. So you can create your own shape on a black background and use it here as a bokeh texture. Now let's see a few renders with different aperture shapes. In the first render, the aperture shape was circular and we get circular out of focus highlights. In the next render, aperture shape was set to bladed and blades number was set to 3, and we get this rectangular out of focus highlights. Then the blades number was set to 4, and we have a rectangular out of focus highlight. And finally, blade number was set to 5. Also, we have this rotation value, which allows us to rotate the aperture and therefore rotate the out of focus highlights. Let's set the blades number to 3 and see how the rotation works. In the first render, rotation was 0, and in the next one it was 120 degrees. And as we can see, we have rotated the out of focus highlights. We have effect exposure. When it's enabled, the custom texture affects the exposure of the scene, depending on the transparency of the texture. And when it is off, the texture always admits as much light as through a circular aperture. For now, let's set the shape to circular. Next, we have center bias. This parameter biases the transparency of the aperture toward the center with negative values or the edge with positive values. Positive values increase the amount of blurring in out of focus areas, while negative values decrease the blur. Now, in the first render, center bias was -50. As you can see, we have a very wide depth of field. Then it was set to 0, which is the default and our normal render, and finally it was set to +50, which produces this beautiful ring effect in the out of focus highlights for now, and also, as you can see, makes the depth of field shallower. For now, let's set it to about 0 here. Next, we have optical vignetting. This parameter, as we discussed in the previous lesson, vignettes the frame by simulating the cat's eye effect that some wide angle lenses can generate. In the first render, optical vignetting was 0, then 2, and finally 3. Negative values for optical vignetting would produce the same result as positive values. Next, we have anisotropy or anamorphic lens section. Here you can simulate an anamorphic lens by stretching the aperture vertically, negative values, or horizontally, positive values, and therefore stretch your out of focus highlights. In the first render, anisotropy was set to -0.75. The effect is a bit exaggerated here, but you can use smaller values to get more realistic anamorphic effect. As you can see, the bokeh is vertically stretched. And in the next render, anisotropy was set to 0, so our normal depth of field without stretching, and finally +0.75, which stretches the bokeh in a horizontal direction. Let's set the anisotropy to 0 for now. And if you want to have depth of field without using physical camera, if you are, for example, rendering from the perspective view, you can do so in the render settings. In the V-Ray tab under the camera rollout, simply enable depth of field, specify the focus distance, and start the render. And all the options are similar to what we discussed in the physical camera, so I'm not gonna repeat myself here. Also, we can produce depth of field as a post effect using the Z-depth render element, but we will discuss that in its own specific lesson. And let's take a look at the two final renders. In the first one, the focus was on the clock. And in the second one, it was on the bottle. We also have the denoiser passes, so let's take a look at them too. I'm just going to color correct one of these images here a bit. Maybe let's set the white balance to 7,200. Just making it a bit warmer maybe. Also, let's enable color balance, enable shadows, and make them a bit bluer. Possibly something like 0.10, 12 would work. And the highlights to -0.15. I'm just gonna save these renders out and possibly crop out some sections in Photoshop to make the composition a bit better. There you have it. In this lesson, we learned about depth of field. It's such an interesting concept and has the potential to make the most boring scenes to be so dramatic. So I will see you in the next lesson with the topic of motion blur.